Hey, good morning and good afternoon to you guys. I really apologize for not being there today. I had a plastic surgery appointment at 3:30 and they called me on Friday and needed to move it to Monday in the middle of the day. And I can't just reschedule that sort of thing. So I really apologize. I appreciate your patience and your understanding. I just very briefly want to talk a little bit about metallic bonding. I've got two really good videos for you guys to watch. The link's right below here. Either Miss Thomas or whoever subbing for you can play them. Or if you are watching this on your own and taking notes on your own, then please make sure you watch it. So first of all, when it comes to metallic bonding, it's not all hugely complicated. I would say probably one of the misconceptions is a metallic bond is between metal atoms of different kinds, which is completely incorrect. When we're talking about metallic bonds, we're talking about bonds that are found between metal atoms of the same kind. So it's like if you were looking at a chunk of gold or a chunk of aluminum or a chunk of titanium, whatever it is, it's just a whole bunch of those metal atoms bonded together. So the glue that is holding those metal atoms together is a metallic bond. So basically what happens, and I know you had a little bit of experience reading about it on two assignments, so you probably already have a good understanding of metallic bonding. What happens is you have all of these metal atoms that are very, very close to one another. They are very tightly packed, very close to one another. And what happens is their electron clouds, think of these as your electron clouds, the electron clouds start to overlap. And when the electron clouds overlap, it's kind of a free-for-all, or it's kind of like the gates open up, and the valence electrons in each of these metal atoms are free to leave. They start to roam around and they start to move amongst all of the atoms' electrons clouds. So when these electrons start to move, okay, and you have fewer electrons than protons, then you actually end up with these cations. So all of these guys right here are actually cations because the electrons are moving in and out of all of these atoms' electron clouds. So what happens is all of these electrons that are flowing in between the electron clouds, they call that the sea of valence electrons. They call it a delocalized sea of electrons, meaning they're kind of misplaced. So these electrons, as they're moving, this is a real good picture for it, there is an attraction between these sea of electrons and these cations. So the metallic bond is actually between the sea of electrons, and the cations. So negative, positive, opposites attract. This sea of electrons really dictates many of the properties that metals have. These guys very easily carry heat and electricity. That's why metals are really good conductors of heat and electricity. That sea of electrons causes a lot of flexibility in metallic elements. That's why our cars are made out of metal. The sea of electrons gives metals the property of malleability and ductility. So also their high melting points and the fact that they're solids at room temperature. So your metallic bonds are going to be very, very strong, giving solids at room temperature, or metals at room temperature, they're solids, as well as high melting and boiling points, because these metallic bonds are really hard to break. That was short and sweet, 4 minutes, awesome. If the sub is playing this for you, she or he will play these two videos to solidify that information. If you are absent and watching this, then please make sure you watch these two videos. Thanks, you guys. Take care. Be good. Bye.